Okay, now we're going to determine some equations from points. Now really, this again shouldn't be anything new. It's really just overlapping some of the previous lessons. But sometimes when I give students a bunch of points in a table and I say, hey, find the equation of the parabola, people freak out and they're like, I don't even know what to do. All the points and information sitting right in front of us. It just sometimes it's maybe tricky to see. All right, so let's remind ourselves, don't forget, we can tell whether this is linear or quadratic by checking the first differences and second differences. So change in y, right? From negative 18 to 0, I'm going up 18. And then from 0 to 14, I'm going up 14, and so on and so forth. 14 to 24, up 10, up 6, up 2. And then it starts going down, right? So 32 to 30, all of a sudden it goes down 2, and 30 to 24 goes down 6. Right? And then we're going down 10 and down 14 and down 18. So that right there should give us a clue where our vertex is. What's the highest point in this? Look at, or in some cases the lowest, but in this case it's the highest. Look at negative 132. Notice how they were going up, 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 and then they started going down. So that right there is our vertex. So that's that point. Now the vertex, right, we can identify it by the highest or lowest y-coordinate. So these ones are going up, 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 up till they hit this point and then they go down. So we got our vertex right there. So that's a key point. Now, the first differences are not constant, so that tells us it's not linear. If we want to double check if it's quadratic, change in y, right, we can find the second differences. All right, so from 18 to 14, right, I'm going down 4. 14 to 10, I'm going down 4, down 4. Notice no matter what, I'm always going down 4. So if the second differences are constant and they're the same number every time, that tells us that this is quadratic. So it's nonlinear, but it is quadratic because the second differences are constant. And the second differences are negative, which tells me that it's opening down. So since change in y is less than 0, that tells me that it opens down. Okay, so there's a few little pieces of information we can pull out of this. So we know the vertex, so why don't we start with vertex form? So determine an equation in vertex form. So how do we do that? Well, we start with y equals ax minus h squared plus k. That's vertex form. And our vertex is negative 1, 32. So that's the h, that's the k. H and k. So we can sub that into our parabola. Y equals ax minus negative 1, so it's going to be x plus 1 squared plus 32. Now, how are we going to find a? That's the only thing that's missing is what is a? To do that, you choose any point. Choose a second point of anything from the table other than one you've already used. You can never reuse a point for any of this stuff when we're finding equations, whether it's quadratic or anything else. You need a different point that's on the parabola. So pick any other point and sub it in. So I'm just going to choose a point here. Let's sub in, let's pick an easy one like 3, 0. There's a nice easy point. I'm trying to pick something that's easy. Like why pick, more challenging numbers, something simple. So there we go. Let's make x 3, make y 0, sub it in, and let's solve for a. All right, so 0 equals a times 3 plus 1 squared plus 32. All right, so we just need to solve for a. So I'm going to subtract 32 from both sides to start isolating a. We have 3 plus 1 here, right, is 4. 4 squared is 16, so we have a times 16. Let's divide both sides by 16, and there we go. I'm just going to flip it around. A equals negative 2. All right, so we found a. So we can write our equation now, right? So our equation is going to be y equals negative 2 x plus 1 squared plus 32. There it is. I'm just going to move this graph up here so I got a little more room. All right, so we know our vertex, right, is at 132. I'm just going to make a little graph here. 1 over 32 up, or sorry, negative 1 over 32 up. So we'll just say that's my vertex there at negative 132. We know that. Yeah, we know what a is. All right, let's find some more other important information. Let's find the equation in factored form, okay? So to find it in factored form, do you have your roots? That's the thing. So let's see. Our roots occur, right, where our x-intercepts are. So our roots or x-intercepts, x int. Now, your x-intercepts always occur when y is 0. So there's 2 of them here, right? Where are they? Let's look at our table up here. Negative 5, 0, and 3, 0. those would be our roots. So they were given to us. So what I'm walking you through here is I'm trying to get you guys to think about, hey, how do, what did they give me in a word problem? What did they give me in this question? Because they got to give you something important. So generally they give you the vertex or they give you the roots in word problems. So whether it's a table, whether it's a word problem, ask yourself, what did they give me? Did they give me the vertex? Did they give me the roots? Did they give me the y-intercept? What kind of points did they give me? So in this case, they gave me the x-intercepts also. 3, 0, negative 5, 0. Okay, so we got our roots. So what do? We sub that into y equals ax minus r and x minus s. All right, so our roots are 3 and negative 5. So when I sub that in, it's going to look like this. Y equals ax minus 3 and x minus negative 5, so x plus 5. Now, once again, the problem is we're missing a. We don't know what a is, right? Right here, no clue. However, we already know what a is, right? We found it up here. Remember, a is the same in all versions of a quadratic. So there's a. But let's say we hadn't done this. Let's say we didn't do that. We have no clue. You would do the exact same thing. Pick a point from, they have to give you in a word problem. They have to give you in whatever situation another point somewhere. So they gave me the roots. They have to give me one more point in the word problem to solve it. So take whatever point that is, pick any other point. In this case, I can just pick any other point from the table, pick something, sub it in for x, sub it in for y, solve for a. But since we already figured out what a is in this case, I'm not going to waste your time and everyone's time by doing all of that. It's simple. It's the same as above. Just sub in a point, solve. But a is the same in all versions, so this a is the same as that a. So I already got it. So my answer is going to be y equals negative 2, x minus 3, x plus 5. Same thing if you're ever doing a test or something. You don't have to redo work. If you know that a is the same in both, that tells me great. You already know it. Good. All right, so there we go. We've got vertex form and factored form, right? So this is the big thing. This lesson's simple, but it's really important because once you start doing some word problems in the textbook, everyone just kind of gives up and go, I don't know what to do. The secret is try drawing a picture. Did they give you the vertex in the question? No. Did they give you the roots? They kind of got to give you one or the other of that. Then what's the other point they gave you? Generally, they're going to give you either the roots or the vertex, and then they're just going to give you some other point, like, negative 324 on the graph or something else. Sub that in for x and y and solve for a, and there you go. That's how you do it. All right, so just back at my drawing here. What do we got here? We know the roots are, I'm just going to finish drawing this, like 3, 0, right? I know one's at negative 5 over here somewhere, negative 5, 0. We also know the y-intercept. Now I'm just kind of glancing over at the graph over here. The y-intercept is 0, 30. There's my y-intercept, right? Because the x-coordinate 0, so it'd be, up here, 0, 30. All right, there's all kinds of points, right, to draw a sketch. Because when you're doing a word problem, and this goes for me too, I always draw a sketch, right? I'm not above drawing sketches. It's important. It's part of the process. It's part of showing you understand what you're doing is to draw a graphical model of it. So don't just do everything in your head. Draw yourself a picture to help yourself out. All right, we're going to do one more example, just kind of showing you of like how a word problem could work and how do you approach it and what do you do, okay? Okay, let's check out another problem here. Now again, this could be like in a word problem, someone's doing this or that. I'm just kind of focusing on the numbers part because if you really zero on what are the numbers they give you, it doesn't matter what the word problem's about. You can figure out the important information from it. All right, so what did they give us here? In this question, I'm given 2 points, 3, 5, and negative 1, 5, right? So I'm just going to kind of draw a rough graph here, over here, 3 over 5 up. So we'll just say that's, I don't know, over here somewhere. There's 3, 5. And negative 1, 5's over here somewhere, we'll just say. All right, not the greatest graph ever, but there we go. Now notice these 2 points are at the same height. That's going to be key because if they're at the same height, right, even though these aren't the roots, they're both at a height of 5. With a parabola, it's symmetrical, right? So if I'm just going to draw kind of a rough, not great drawing of this, right? Boy, that's rough, eh? That's rougher than rough. Okay, if it's symmetrical, so these points, we can find the vertex here by finding the halfway point of those. So step 1 in this case, and determine the equation to represent this parabola. Okay, so let's start by finding the axis of symmetry, which is halfway between. Find the AOS, right? That's halfway between these. So what we're going to do is add the 2 x coordinates together, negative 1 plus 3, and divide it by 2. So we're going to end up getting x is 1. That's the x-coordinate of my vertex. So up here on my not-so-great drawing, the x-coordinate is 1. Now, I don't know what the y-coordinate is, but I know that's the x-coordinate. Now, I also know this thing opens down because before I even drew it there, I knew it opened down because it says it has a maximum value. So the maximum value, that tells me it opens down because it has a high point. If it said minimum, it would open up, right? So we know it opens down. And now that I'm looking over here, they're telling me it has a maximum value of 21. Well, that's the y-coordinate of the vertex. All right, so guess what? It's 1, 21. So we have just found the vertex. So now I have to decide, I have to find an equation for this. So part A says determine equation. So we could try to find it in vertex form or factored form. I would use factored form if I had the roots. I don't have the roots. I have 2 points they gave me that are at the same height, which help me find the vertex, but they're not the roots. I have the vertex though, so I'm going to go with vertex form because my vertex is 121. So vertex form, let's write it out again. Looks like this: y a x minus h squared plus k. Now, if they had given me the roots, I would just subbed in and found my roots. I would just subbed in a factored form. H and k. So there they are. So let's sub in. We have y equals a x minus 1 squared plus 21. Now, just like the previous problem, the only thing we're missing is a. So choose a point, sub it in, and solve for a. So we can use one of those 2 points we're given. We haven't used those yet in this formula. So let's sub in one. So I'm going to sub in, doesn't really matter, I'm going to sub in 3, 5, okay, for x and y. And let's solve for a. All right, so 5 equals a x minus, x is supposed to be 3. 3 minus 1 squared plus 21. So here we go. I'm going to go 5, subtract the 21. And on this side, we have 3 minus 1, which is 2, and 2 squared is 4, so I have 4 times a, or 4a. I can just write it like this. All right, 5 minus 21 is negative 16. Divide both sides by 4, and there we go. We get a equals negative 4. All right, so I finished part A. I found my equation. Y equals a is negative 4, x minus 1 squared plus 21. So you want to take the easiest path. If they give you the vertex, use vertex form. And we had the vertex here. They gave us enough information to find the vertex. If they give you the roots, use factored form. All right, what's part B say to do here? Part B, determine the y-intercept. Okay, that's easy. The y-intercept. It's not in standard form, so I can't find it right away. But every graph that you ever do for the rest of your life, the y-intercept occurs when the x-coordinate is 0. So just set x equal to 0, and there you go. So let's take our equation. Negative 4 times 0 minus 1 squared plus 21. And see what the y-coordinate is, right? So this doesn't just apply to parabolas. This applies to any graph of anything, right? Same with our roots. When we find our roots, we set y equal to 0, right? It doesn't matter what the equation is. All right, so where are we at here? All right, so we have negative 4 times, what is 0 minus 1 is negative 1 squared is 1. So negative 4 times 1 is just negative 4. Negative 4 plus 21 is 17. All right, so my coordinates of my y-intercept are 0, 17. All right, so 0 over 17, again, this graph's not drawn great, would be right there. Okay, so we got that. Let's do the final part. So we've done, what have we done so far? Yes, determined equation, did it. Found the y-intercept. Now let's find our x-intercepts. So I'm just going to pause the video and erase the space so I have a little bit more room here to keep going. So, but remember, to find the y-intercepts, you set x equals 0. So find the x-intercepts, you set y equal to 0. All right, so here we go. Back up part C, finding the x-intercepts. Now this here, like I just said, let's set y equal to 0 in equation. So let's take our equation we just had and set y equal to 0. So 0 equals negative 4 times x minus 1 squared plus 21. Now here's where people make a big mistake in just the amount of work they do to solve this problem. Some people simplify this whole thing, put it in a standard form, then they use their quadratic formula. That will work. Don't get me wrong. It will work. You can simplify this and use the quadratic formula to solve for the roots. But that's going to take a long time. All we need to do here is isolate x. So let's ask ourselves what's happening to x and do the inverse operations. Okay, so what we're going to do is we're going to isolate x. So let's just go through the inverse operations like I said. So like what's happening to x first? Well, here's x. The first thing that's happening is you're minusing 1. The second thing that's happening is you're squaring it. The third thing that's happening is you're multiplying by negative 4. And the fourth thing you're happening is you're adding 21, right? That's the BEDMAS operations. Inside the brackets, then the exponent, then multiplying, then adding. So what we want to do is undo these in reverse order. We're just isolating x, right? So the first thing I want to do is the last thing there, which is we're going to get rid of the plus 21 by moving it to the other side. Subtract 21 from both sides. Negative 21 equals negative 4 x minus 1 squared. All right, what's the next thing we want to do? Divide both sides by negative 4. Okay, so we're going to have negative 21 divided by negative 4, right? So that's just going to give us positive 21 over 4. And we have x minus 1 squared. All right, the next thing we want to do is get rid of the square by square rooting both sides. So we're going to have plus or minus the square root of 21 over 4 equals x minus 1. And the final thing we're going to do is add 1 to both sides. So 1 plus or minus the square root of 21 over 4 is x. So there's your 2x values. I'm just going to flip this around here, and this would be my exact values. So the exact roots, or your exact x-intercepts, would be, now they're going to be decimal numbers, right? But the exact way of writing it would be 1 plus or minus the square root of 21 over 4. Now, if we need those as decimal numbers, we're solving a word problem, it's time or something like that, we need to get an answer. Okay, well, we'll just punch in our calculator. What's 21 divided by 4? Take the square root of it, and then we're going to take that decimal number and get two possible answers, 1 plus that decimal and 1 minus that decimal. So just to save time, I calculated those already, and you can double check. You get the same thing on your own calculator. You should get x is approximately 3.3, or x is approximately negative 1.3. So if I go graph those on my graph up here, right? All right, up here, right, there's where the negative 1.3 over 0 up would be, because remember we set y equal to 0, and the other one would be at 3.3, comma 0. All right, so there's another essential skill, whether you're doing grade 9, grade 10, grade 11. Anytime you want to find your y-intercept, you set x equal to 0 and solve. Anytime you want to find your x-intercepts, you set y equal to 0 and solve. Sorry, maybe I had those mixed up now. You get the point. Y-intercept, set x equals 0. X-intercept, set y equal to 0. All right, that's it for today's lesson. Now again, when you're doing the word problems and all the different questions in the textbook, you're going to have to use a mix of all these skills. It's not like each question just says, just find this or just find that. You're going to have to use a mix of all these different skills, because these are all skills we learned in grade 10. We're supposed to know them pretty well. So this is a combination when you do the word problems of each of these. What do I need? What skills should I use? What tactics should I use to find this stuff? Okay?